Okay, today is Tuesday, the 7th of July, 2015. This is John Linville with a little video update on my Retro Challenge project, which is to explore some helpful little additions we could make to CoCo game cartridges that might give us better games. Those of you following my blog may have already seen that I had a little disaster. I had planned to use this Breakout board, which has the same number of dip style pins as the CoCo has for its cartridge output. I was going to use that along with this IDC cable and some other little Breakout stuff to get access to the CoCo cartridge port. Unfortunately, this Breakout board, which is made for the Raspberry Pi 2 B+, I guess. As you can see, the connections are labeled according to how the Raspberry Pi 2 uses them, no doubt. And the problem is those that are marked G and D for ground, the designer of that board has helpfully tied them all together. And unfortunately, when you adapt that into the CoCo through this lovely contraption I have set up here, it ends up shorting between power and plus 5 volts and ground, and so it just doesn't work. So for now, I was hoping to get some more complicated circuits, but fortunately I started with a fairly simple one. So here's my Breakout now, which is literally just wires stuck into the pin receptacles on this IDC connector. So anyway, again, this circuit is fairly simple. If we get close enough to it, maybe it'll focus in, or maybe not. Anyway, it's a 555 timer. It's just getting power and ground and from the CoCo and sending back a signal on the interrupt line. The calculation for the frequency here is right at the 4800 hertz. So it should be sending in an interrupt. It's actually in the fast interrupt line for the 6809, coming in at 4800 hertz. And then I've got a little piece of code that's usually the sync instruction now, just to monitor that line. It could be a interrupt handler in a program, whichever is convenient for you. But the whole point here is to be able to use the fast interrupt line in order to potentially generate audio using an interrupt handler. Anyway, that should be, like I said, the calculations for the timer circuit put us right at 4800 hertz. That's a toggle, so each one is up or down. So the actual frequency output should be about 2400 hertz. This is using the 1-bit audio output from the CoCo, which some systems call a beeper. Well, it's similar to the 1-bit audio on the Apple II. Anyway, this is just a very simple setup to illustrate the point, but it kind of proves that the idea works. So here I'm just going to demonstrate that if I pull this wire, if I pull that wire that generates the interrupt line and the interrupt signal, this 10-tone stops, and when I plug it back in, it starts again. So anyway, not much of a demo, but that's what I've got today. So I hope you enjoyed. Thanks for watching, and if you want to see if I can recover from my little equipment disaster, then I guess you'll just have to stay tuned. Thanks.